Good day, everyone, and welcome to our math lesson for today. Today we're going to do indices, fractional indices. So we've already learned about the normal indices where we had our bunch of rules that we had to write down, but now we're actually going to work with indices that have fractions. But before we go to that point, we need to learn our rules. Now our first rule states that a number to the power of a half is equal to the root of that number. Okay, and a number that is to the power of 1/3 of that number is equal to a cube root. So therefore, x, or a number to the power of 1/m, is equal to a root of m as its power. Okay, so, but we're going to practice all of that here. We just need to see what the rules are. Okay, also, when the power has a fraction, right, we can put the power in our root, and then the base of our power would be our power of our root, and the numerator of our power would be multiplied by that root that we are making. Okay, thus we can also say that because that power of the root with the number that we're working with is multiplied by the numerator of that root, we can also say that the power of the root is the numerator of the root. So I know it sounds weird, it sounds difficult, it sounds confusing, but believe me, when we start working it out, calculating it, we will see that it's not that difficult. Okay, so we're going to start with the easy one and going off to the difficult one. Let's start with question number 1. Question number 1 states y to the power of a half. Now, our rule states that we need to solve this. So how do we solve this? When there's a number with a power of a half, it would be equal to a root of that power. So the answer of this would be, if we simplify it, it would be the root of y. You see, as easy as that. So y to the power of a half is equal to a root of y. Let's look at number 2. Number 2 says x to the power of 1/5. So how would we solve that? If we have to follow the same rule as we did here, which we said x to the power of a half is equal to the root of x. So how would we solve this? If we can also say that x to the power of 1/3 is equal to the cube root of x. You see that 3. This 2 goes here because this is the invisible 2, right? So it goes here. This 3 goes here. So if we have a 5 at the base here, what would our root be to? Yes, correct. So our root would be 5. And that is our answer. See, I told you it's going to be easy. Okay, so question number 3. Question number 3 states that we need to solve we need to write this in index form, sorry. So if we need to write the root of 90 into an index form, remember index form is when we have a to the power of n. That is how index form looks like. That's what we need to write with this. So as we have the root here, and this would be the inverse or the opposite of it. So we can then say that the index notation of this equation would be 90 to the power of a half, isn't it? Okay, so let's look at question number 4. Question number 4 states, we still need to write in an index form. This would be cube root of 64. Okay, so how would we write it as in an index form? We do the same thing, so the number in the bracket here will become our base, right? And the number here would become our index, so 1/3. And it's as easy as that. Let's look at number 5. Number 5, we have 4 root x. How would we write that into index form? We should be experts by now. We put the x, the base, we write it there, and we put it to the power of 1/4. Where did I get the 4 from? It comes from here. So that 4 travels over there. You see here the 3 travels over there. And you know this is an invisible 2, so that invisible 2 goes to there. So it's as easy as that, guys. Just follow the rules in math and you'll do just fine. Okay, so let's do number 6. Number 6 states the root of x minus 2 to the power of 5. So how would we solve that? Just the same way as we did here. Don't let the brackets scare you. Okay, so we rewrite the base. So we say equal to x minus 2. Okay, keep that in a bracket. Okay, and then what do we travel? We travel the 5 outside of the bracket. So 1/5. And that is our answer. So x minus 2 to the power of 1/5. You see, not that difficult. Let's look at number 7. So number 7 states that it's 27 to the power of 2/3. Now, this one looks a little bit different. It looks a little bit weird. Okay, but again, if we follow our rules, then we would not have a problem. Okay, so this is the rule. This one over here, that's the rule that we're going to follow. Okay, so let's look at that. We say equals to, what does the rule say here? We need to put that in a root, isn't it? Okay, so we take the 27, we write that down as our base. Then we do the root. What would be our root's power? It would be the 3. Okay, and then we need to multiply. We need to multiply this by the root of 2. By the square of 2. So equals to, so what would be the root, the cube root of 27? Here we can use our calculator. Okay, so by using our calculator, what button are we looking for? We're looking for this button that says the root, and then they put like an X there or a star there, right? So that's the button that we're looking for. So we press 3, then we use that button, and then we put 27. Then we say equal to. So the root of 27, the cube root of 27 is 3. And then we have 3 to the power of 2. So what is 3 squared? 3 times 3 gives us 9. And that is our answer of our equation. Okay, let's look at our second last question. Our second last question says at number 8, 25 to the power of 1/5. Okay, but hold on, we can't just do a decimal point. Yes, you will still see decimal points as a power. You will sometimes see it. It's not that common, but you still need to know how to solve it. So how would we change this number into a fraction? Okay, so the fraction for this, if you put it into your calculator, right, you have 3/2. Okay, because it's 3 parts of a half. There's 0.5 plus 0.5 plus 0.5 gives us 3. So this will be 3. And what is a half of a fraction? It is 1/2. And that's how we know what number to use. Okay, so we use 3/2 when we're working with this. So we say equals to 25 to the power of 3/2. And then we follow our rules that we have learned just now. So what does our rule state? This one again. the rule states that we now have to rewrite our base into a root. And what would our base of our root be? It would be square, so we don't have to write anything down. But this square is multiplied by a cube. And now we need to find out, what is the square root of 25? What multiplied by itself gives you 25? That would be 5. But hold on, we still need to cube it. So what is 5 cubed? So 5 times 5 equals 25. And 25 times 5 gives us 125. So the answer here is 125. Okay, so you see, if we follow the rules, we can still solve this. Doesn't matter what they hit us with. Just keep calm and follow the rules. Let's do our last equation. If 2x equals to 128, find x. So if 2x, so that's number 9, 2x equals to 128, what would x be? How would we solve that question? Okay, so the way that I would necessarily solve this equation is I would use my prime factors to find the product of prime factors for this number. Okay, so that's what we're going to do now. So we say 128. Our prime numbers are 2, 3, 5, 7, not 9, sorry, 11, 13, 17, 19, and 23. Okay, so 2 goes into 128 how many times? Gives us 64. So here is 2, here is 64. 2 goes into 64 how many times? 2 goes into 4, 2 times. Let's write that down. 2 times 2 goes into 6, 3 times. 2 goes into 32 how many times? 2 goes into 2. Okay, that doesn't work. So it would be 16. So 16. And 2 goes into 16 8 times. And 2 goes into 8 4 times. And 2 goes into 4 2 times. Okay, so let's count how many times did we have to root 2 or power 2. 1, 2, 3, 4, 5, 6, 7. So then 2 to the power of 7 would be equal to 128, which means this is not the answer yet. They're looking for x, which means you need to say x is equals to 7. And that is what we get our answer. Or that's how we get our answer. That's why prime factorization is also very important to understand and to know that. Now, again, like I said, this looks confusing. This over here looks really confusing. But if you follow the rules, just like they've been pointed there, then you will be able to solve these equations. Okay? So again, if you don't understand this, let me know. Write in the comments. I'll make another video that's a little bit slower, that's a little bit more in detail, with a little bit more rules, and I'll see you again later. Goodbye.